An earthquake is really a rupture or a break of the rocks that happens suddenly. The stress builds up over years, decades, even hundreds of years, but the earthquake happens all of a sudden. Why? Why on that particular day?
Harold Tobin aims to find out as he and his colleagues drill deep into the ocean floor off the southwestern coast of Japan.
The biggest faults in the world are the ones that make the magnitude 9 earthquakes and the tsunamis, and they're all offshore. They're all underneath deep water in the ocean. We'd like to actually get inside the fault zones themselves, deep beneath the surface, in order to learn about the properties of the rocks and what the stresses are and what's building up the strain. So the only way to do that is actually to use a drill, just like sort of the oil drilling field, but using it for science instead of for drilling oil wells, to get down into those faults even kilometers below the surface. We're drilling holes as deep as 4 miles, 7 kilometers below the surface, in order to get at those fault zones, because we have to get to where the earthquakes occur, and they occur really deeply. We drill down and we can take core samples, so we can take rock samples, sort of meter by meter as we go along, and look at what that core tells us about the geology. We can also put instruments down in those holes so that we can measure things we'd like to know, very small earthquakes using special seismometers that go in the borehole, or strain of the rock, or maybe the temperature of the rock at those depths, and monitor that over time to look at how it changes in those faults between earthquakes and maybe leading up to the next big earthquake.
In 2006, the team started drilling in the Nankai Trough, a region that has experienced a large earthquake and tsunami about every 100 years. The team has already come up with big surprises.
One big kind of surprise that's revolutionizing the way we're thinking about these faults a little bit is we drilled into the fault actually at a quite shallow position, just sort of a few hundred feet below the surface, and found really good evidence that the earthquake slip had come all the way to near the surface at the seafloor there. That tells us that when one of these deep earthquakes starts, it can rip through the rocks right up to the seabed, and that's really what makes the tsunami potentially so damaging, is when it moves the seabed a lot. So it's really changing the way we look at how these faults go when a big earthquake occurs.
Tobin also runs a geoscience visualization lab at the University of Wisconsin-Madison that creates 3D models of the drilling locations.
There's also a very practical goal, is once the beginnings of an earthquake rupture start to happen, how quickly can an early warning be formulated, and how quickly can we estimate that it's not a little earthquake, it's really a big one that's starting, and over just seconds determine that a warning needs to go out to, say, nearby populations. And so wiring up this fault zone off the coast of Japan is one way of getting at that problem, and then getting the data back real time, onto the internet through these seafloor observatories, so that those kind of warnings can go out.
Warnings that might save lives on the particular day when an earthquake strikes. We can never know exactly when the next big one will occur, but the work of Tobin's team can help us determine the likelihood and timing of these events.